All right. Hello, everybody. We're here to talk about science, and unfortunately, Brock and Garrett are not here today. So this is for you guys. Happy birthday to you. Happy birthday to you. Happy birthday, dear Brock and Garrett, your twins. Happy birthday to you. I just want to throw that in there. Happy birthday to all of you. Well, we can't have candy without them. I was planning on giving candy to the whole class today because it was their birthday.
Okay. You should still.
So
we can do Friday and Monday.
So we have no school Friday. Remind me Monday. Remind me Monday. Remind me Monday. I'll give you all candy Monday in honor of their late birthday. All right. Into the candy drawer to like have them like symbolically going to grab the candy. I'm gonna do it. Yeah, you know, everyone come get some candy. All right, everyone come get a piece of candy. All right, here we go. Everyone get their piece of candy. There we go. All right, we got it. Everyone else can get their candy now.
I am the negotiator.
Oh my gosh.
I am
so easily entertained.
It was incredible. I'm looking out for you, big man. I'm looking out for you.
All right, grab your piece.
Bro, my agenda's been up there for like 5 minutes.
All right.
They got
Excellent. Also, Danny and Emily, we miss you too. And Isaac, yes. We miss, and Landon. We miss all of you. But it's not your birthday, so. All right, here we go. On the AP Classroom questions. For a demonstration, the chemistry teacher puts 2 powders in a beaker and then puts it on a small wooden board on a wet surface. It freezes, right? It freezes to the surface. I don't want this to be frozen. Oh, snap, don't look at this. That's everyone's grades. All right. All right, here we go. All right, now we're good. Freezes to the surface. What is it? Let's see how you guys did on this one. Why is it not showing me who got what right? Oh, here we go. What?
That's full screen.
Why is it not doing that? I don't like how this is like looking. Here we go. That's a little better. That's the way. Well, 3 people didn't do it at all.
I woke up and I almost cried because I was like, I forgot.
I'm sorry.
Yes,
And this is endothermic. D, it's endothermic because it's taking energy into the system. Therefore, it feels cold. It took energy out of the water. That's what made it freeze. That was the first one. Second one, evaporation of ammonia. Which of the following phase changes as a transfer of heat from surroundings to the system? So which one of these do you have to put energy into? Most people got it. This one, because I'm going from a liquid to a gas. In order to make something go from a liquid to a gas, you have to put heat in. Cool? That was number 2. Number 3, reaction profile. I was a little surprised on the amount of people that missed this, which it's fine. So we have equation xy2, and it says, which of the following best describes the flow of heat when 1 mole decomposes? So my reactants are here, my products are above. We said that was endothermic, right? So that means 50 kilojoules of heat was transferred from the surroundings into the reaction. So it had to be 50 kilojoules into the surroundings. 150 minus 50 is 100. I'm sorry. 150 minus 100 is 50. It's the difference. It's the difference. Cool? Okay. That was that one. Next one. Most people got this. Which of the following best explains why the student's prediction is correct? So we're saying that the Fe atoms are more massive, so they'll have a higher kinetic energy. No. If they're at equilibrium, that means they're all the same, no matter what the mass is. No matter what the mass is. So that's why that was D. Next one, temperature change. I really like this one. This is a great thinking question. So there's air. Or no, this was just sig digs. This was just sig digs. Oh, yeah. So on this one, let's talk about it. I can read to what? I can read to the ones, right? Therefore, my guess number is to the tenths. So this would read as 22 point something, right? Agreed? This would read at 29.0. When you take something with 1 after the decimal minus something with 1 after the decimal, how many do you have to have after the decimal? 1. Therefore, A. So that had to be A. Do I think you'd see something like that on the AP test? Probably not, but that was that. Next one, we're looking at this heat curve. Temperature was recorded as 50 grams of ethanol was heated at a constant rate, which of the following explains why the slope segment of T is greater than R. Well, T must have a lower specific heat, which means it can more easily be heated, right? The higher the specific heat, the longer it takes to heat. The more good, I can't think of the word, the better, there you go. The better it can hold in heat. Water has a high specific heat, so it takes a long time to heat up, but it also holds that heat in well. So, lower specific heat, higher slope. That was number 6. Number 7, on this one it's saying, why is D longer than B? So at point B, what am I doing? I'm melting it, right? So, and at a point D, what am I doing? I'm evaporating it. Which one is going to take more energy? Going from this to this, or from this to that? The second one, right? It takes more energy to completely break a molecule away than it does just to get them to slide past each other. Which was, what's that? Yeah, it takes more energy to break them away than make them wobble. So D, the enthalpy of vaporization, is higher than the enthalpy of fusion. Because separating molecules completely requires more energy. I thought this was a better description than that. Right? Thank you. All right. Questions? Okay. I've had a lot of sugar today. Number 8, calorimetry experimental error. Okay. This is a great question. Which of the following would result in the least error calculated? Let's talk about all of them starting bottom up. E, the final temperature was taken before it's reached equilibrium. Well, that's going to affect my change in temperature, right? That's going to create error. D, the actual molarity was 0.53, but it was recorded at 0.5. That's going to change my number of moles. That's going to change my number. C, the calorimetry was poorly insulated and some heat escaped. That's going to change my answer. Agreed? B, the volume was 1 milliliter less than recorded. That's going to change my answer because that's going to affect the mass. Letter A, the thermometer was incorrectly calibrated in 0.5 too high. Well, here's the thing. If I start 0.5 too high and I end 0.5 too high, does that even affect my data? No. That's why it was A. This would not affect the change in temperature. Does that make sense? If I start 0.5 too high and I end 0.5 too high, my change in temperature will be the same as starts regular, ends regular. Make sense? Okay, cool. That was, what number was that? 8. That was it. That was it. Take a look at your little two-pager. Which looked like this. Number 1, I graded 5 questions on this. The other 5 was just, did you do it? Number 1, you should have had 140.3 megajoules per mole. Number 2, I didn't grade, but what determines the position? So position is identified by ionization energy, and the height is how many electrons are in each orbital, right? 3, why is the distance of energy level from the nucleus important? Well, the closer the electron, the more attraction, right? So the closer it is to the nucleus, the harder it's going to be to remove it. 4, based on the information, draw a photoelectron spectrum for argon. So that would have looked, I don't know why I didn't do that. Let me do it really quick. So argon, it would look something, here's my graph. So this would be 1s2, 2s2, 2p6, 3s2, 3p6, right? Okay? So that was argon. And then number 5 I graded, because it said which one is it? Well, number 5 was magnesium, right? 5 was magnesium. And then 6. I graded 6A and B. 6A said identify if either of the following statements is correct and then explain your reasoning. Letter A. The photoelectron spectrum of Mg2 plus is expected to be identical to the photoelectron spectrum of neon. I agree that they are isoelectronic and have the same number of electrons, but what do they have a different number of? Protons. And if they have a different number of protons, then the shifts on the peaks on one of them are going to be shifted a little bit closer to the nucleus, because the nucleus can pull more. So that first one was false. So 6, the answer was no. 6B, the photoelectron spectrum of 35 Cl is expected to be identical to 37 Cl. Yes. What am I only changing between these? I'm just changing the what?
Neutrons.
The neutrons or the mass. Do those affect charge? No. So B was yes, those would be the same. And finally, number 7, is it possible to deduce the electron configuration from an atom from its photoelectron spectrum? Yeah. You can look at the number of peaks, how high they are, and you can just figure 1s2, 2s2 from the peaks. So that was yes. So I graded those 3. Lastly, number 8, why is the peak in the K photoelectron spectrum identified as being in the 4th energy level? Well, there's 6 peaks, right? So each one must be the next closest orbital. I didn't grade that one, but that was number 8. Questions? Okay, so that was 10 points. Lastly, the photoelectron Pogil. First page was pretty straightforward. I didn't even write any answers. Questions on page 1? Page 2, and I gave you 10 points. You're welcome for having this done. I thought that was super generous. Super generous. Number 5, did you have KE kick equals PE but plus KE roll? Yes. What force of attraction holds the electrons in the hydrogen atom? You should have had like Coulombic or like nuclear pole or something about that. Reese.
I should do the question on page 1.
Okay.
It says what type of energy must the ball have to get out of the ditch? What type of energy must be overcome to get the ball out of the ditch? So you'd have to overcome gravity to get the ball out of the ditch, right?
Right.
So does gravity count as potential energy then?
Potential. It's stored energy. Because you don't have gravity, something can be not moving, right? The ball is not moving, it has potential energy.
Yeah. But
So that's-
the force of gravity is acting on it, right? Like,
Yeah, but it's not moving it. So that's potential energy. There has to be movement in order for it to be kinetic energy.
And gravity's acting on you right now, but you aren't moving.
Right. You have potential energy, you have no kinetic energy right now.
like
Except for how you just whipped your hair. That'd be kinetic.
so also what does it mean as an overcome potential energy?
Overcome, make it move.
But like you're still like
Like right now, I have potential energy, right? In order to overcome it, I have to move.
whoa.
I know. That's what it means. Thank you, though. Good questions. Okay. Over here, Coulombic potential. So which type of energy needs to be overcome to remove an electron? Potential. We were just talking about that. What is supplying the energy? A photon. A photon supplying the energy. And then for gravity, I said the Coulombic charge or number of protons, however you wanted to say that. The ball was the electron, and the player's kick was the photon that you were shooting at it. Okay. Next page, I wanted you to look at number 12. Kinetic energy of a photon is ionization energy plus kinetic energy of an electron. You guys have that? Okay. Some of you just turned it in, so. 15, did you have 9,000 or 9 times 10 to the third kilojoules per mole? Yes? You remember having that? Great. 17, obviously A has to have more energy. Moving on. 19, I want to talk about this one. Compare electrons 1, 2, and 3. Did you have 1 equals 2, which is greater than 3? Because I lose 1 electron. Have I lost any shielding yet? No. I lose the second electron. then I've lost a level of shielding, right? That's why. Down here, some pictures. Any questions on this part? That part was pretty straightforward. Next page. Next page. Why is there only 2 peaks, not 3? Well, there's only 2 energies. You guys should have had that. Here, did you have 1s2, 2s2 the same height? A better picture than me, even though mine aren't the same height? Yes? Okay. Sulfur and phosphorus is here. So we get our shell models, the 2624 stuff. Sketch the PES spectrum for chlorine using model 5. Did you have 1s2, 2s2, 2p6, 3s2, 3p5?
Yep.
Probably.
Probably. And your heights were probably better than mine.
Do you want us to like write things to and stuff about it?
No, you don't have to. So on the AP test, it's really weird grading questions like this. So there was a question last year, we haven't got to this, but it's about like distance between nuclei, and you had people to like draw where it would be. So it's like, if it's no higher than this, but lower than this, count it. Like, questions like that are super hard to grade. Because like if someone draws it close, it's like, do you count it or do you not count it? So I think this would have got the point. But just make sure that your peaks are the same when you're doing it. Hi, Mr. F.
That's cool. Why did you just walk through here?
Why? The quickest way between 2 points is a straight line.
You have to walk like all the way around and then go.
It's actually like a lot longer going that way.
Yeah.
So, 32. Did you have 2.38 times 10 to the negative 16th joules?
Yeah.
Okay. On B, you may have had, instead of 0.011 times 10 to the negative 16th, maybe you had 1.1 times 10 to the negative 18th, depending on how you did it.
Yeah.
Okay. On C, I had 660 kilojoules per mole. Johnny remembers all of these.
I have a good memory in this.
I don't remember this.
33 is a good one. Anybody think they have a good answer for 33?
Can you read it for me?
33 says, how are photoelectron spectroscopy and the photoelectric effect related? Reese.
So what I wrote is that the photoelectron spectroscopy, spectroscopy,
Yeah, that's a tongue twister.
spectroscopy used or applies the photoelectric effect to atoms and molecules.
I love that answer. The photoelectric spectroscopy is just a visual of the photoelectric effect. It's just showing this in graph form.
I did not have that.
Just showing that it applies this. Good answer. 34. 34, I had 3.5 times 10 to the negative 7th, or 350 nanometers.
Oh, I have a good.
Either one's okay. So you need to do IE. So I took my joules per mole. I multiply that by 1 mole, 6.02 times 10 to the 23rd electrons. That's 5.65. HC over E. And then that gave me my 3.5 times 10 to the negative 7th, or 350 nanometers. Why high vacuum conditions? If there's air, what could those photons run into? Other particles, right? Has to be in high vacuum where they're going to run into other particles before they hit the metal and knock off the electron. That's why. Yeah. Okay. Cool. Will you have to do some kind of math like this on the AP test? No. You would never have to do math that in depth, but it's good to practice. Cool. For the rest of today, you are going to finish or do the Coulombic Pogil, which you guys should all have. Everybody's second period finished it in the time that they had left. It's super fast compared to this one. If you already turned it in, then you can work on lab calculations or do something else. So get together, do that Coulombic Pogil, get it turned in. Happy birthday again.